Hello everyone. Today I'm going to be doing three types of rational functions, and we'll start out first with the multiplication one. For this one, we'll do number 1. So to begin to solve this equation, we need to first factor it out or draw out its factors. So I'll start with this one right here and using the diamond method and do -5 over -4. Something that multiplies to -5 is -1 times 1, but that also adds up to -4. So that works as a factor. And then I'll do that for the one on the bottom too. And that'll be x plus 3 times x plus 3. And over here, all I can do right here is just simplify and take out 2x to leave x plus 3. And this one, we do that to get x plus 2 times x plus 1. Okay, now that we're here, the next step we need to do is we need to set our restrictions. And so the way we do that is we set each of these factors on the denominator to 0. And so the restrictions for this one would be x equals cannot equal -3, -2, or -1. And the reason we do this with the restrictions is because we can't have 0 in the denominator. And if we plugged in any of these, we would have 0 on the bottom, and that would cause it to have a problem of something being divided by 0, which you can't do that. Okay, so now that we've reached this point, we can just cross cancel. And we're left with 2x times x minus 5 over x plus 3 times x plus 2. Now, and after this, we would just multiply it all together. Get 2x squared minus 10x, and then x squared plus 6x plus 6. And that is our final answer for this problem. Okay, moving on. For this one, we'll be solving rational equation, and we'll do number B. So what you want to start out doing with this problem is to first find the least common denominator, or common denominator. And you will do this by seeing what is under in each denominator and so what needs to be there. And you do that by multiplying all denominators together. And so you end up getting it so that would be x plus 3 times x minus 4. So now that I have this least common denominator, we'll want to multiply this least common denominator by the entire expression. And so we would multiply this right here. And in this equation, x plus 3 and x plus 3 would cancel out to leave you just the -4 times x minus 4. And so that ends up with -4x plus 16. For this one, x plus 3 and x plus 3 cancel out again. So it's x minus 4 times x minus 1, which ends up being x squared minus 5x plus 4. And this final one, the x minus 4's, both cancel out. So it ends up just being x plus 3 times x to get x squared plus 3x. We'll want to factor this down further, but how we would do this is we would set it to 0. So I would add 4x to both sides. Well, actually, before we do that, let's just add everything on this side together to be 2x squared minus 2x plus 4. And then let's add 4x to both sides and subtract 16 from both sides to get 2x squared minus, no, plus 2x minus 12. Now the next thing we can do before we start factoring, the next thing we'll want to do is to factor it down even further and see if there's anything I can take out at this moment. And as it turns out I can take out a 2. And so this turns into 2 times x squared plus x minus 6. Now that I've reached this point, I can diamond and do negative 6 over 1, and I would get positive 3 times negative 2 is negative 6, but it also adds up to 1. So that'll work. So those would be our factors. X plus 3, x minus 6 times 2. To solve this down even further, we would set each of the equations to 0 to get that x be negative 3 and x would be 2. Now, now that we have our two x's, we need to see which one is extraneous or cannot work. So we forgot to do it at the beginning, but using the denominators, we can set restrictions. So that x cannot be negative 3 or positive 4. Because if we were plugging negative 3 here, it would cause it to equal something divided by 0. Plugged in 4 here, cause it to equal something by 0. So with these restrictions, we can know that the x does not equal negative 3, but that x equals positive 2. And so that would be the answer to that equation. We'll next be able to see how we can graph rational functions. What we want to do here is we need to first find out its domain. And the way we do that is we would factor out the bottom right here. So let's have space up here. Factored out with negative 6 and 1, and that would be 3 and negative 2. So that means that the equation will end up looking like x minus 2 over x plus 3, x minus 2. And so we can know that x cannot be negative 3, positive 2. And so that means that our domain is x does not equal to negative 3 or positive 2. Okay, so we have this equation up here. And we can actually simplify it further. Since there's the x minus 2 on the top and on the bottom, we cancel this out so that in the end, it will look like 1 over x plus 3 equals f of x. Yeah. And this is really good because it means that it will look a lot like our original parent function of 1 over x d of x, but it will just, when we graph it, it will just be 3 to the left.
That works pretty much all the way.
Now, because of the x plus 3, we can know that the asymptote will be at negative 3 because we know for sure it cannot be at negative 3. We established that here. And we still keep the asymptote of 0 from the original parent function. Nothing changed there. And so our graph will end up looking like, I'll just sketch it right now, will look something like that and that. With the vertical asymptote being at negative 3, the horizontal asymptote being at 0. So we need to find the removable discontinuity here. So we know that x cannot equal 2. So that means we go to 2, and we go up until we meet the line, and then we make a circle right where the line is, because there technically cannot be a point right there. So we need to find what the y value of that is, because we cannot have that, and we need that for a range. So we would simply just plug it in, where it's 1 over 2 plus 3. So that ends up being y 1 over 5. And that means our range is y cannot be 0, and y cannot be 1/5. And that's all we need. We found the domain, the range, the two asymptotes, and the removable discontinuity. Thank you so much for joining me today. I hope you have a wonderful rest of the day.